Hello and welcome to Physics Problem 1 by 1. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Today is another installation about quadratic function because I want full understanding what you need to know and how it works, because it would be useful for you in physics and also in math. And in any engineering, you should know it. So last time we talked about ax squared plus bx plus c, canonical expression of a polynomial of second degree where a is not equal to 0, b is not equal to 0, and c is not equal to 0. And we talked about completing to the full square. And right now I want to use the same method just to derive those two formulas, those solutions. Because you, of course, remember those things, you have to remember those things. You have to memorize that how to solve this quadratic equation with those two formulas, b squared minus 4ac, it should be embedded in your memory. But if you've forgotten, let's see how we can derive this formula. And to derive this formula, we take this thing and we start working with this. Remember, we have u plus v squared equals u squared plus 2uv plus v squared, right? And so what we do here, we will take out a, because we will be doing x squared plus b over a x plus c over a. And you see, I can take a out and divide over 8 here, put 8 into the denominator, because I know that a is not equal to 0. Because if a is equal to 0, this becomes polynomial expression of the first degree. And we're talking for sure that it is second degree, so I know that it is this, right? And let's say I'm solving this, I say equals 0 equals 0. So I get rid of this, and I have this bracket. And I start to rewrite this bracket, and this bracket equals 0, and I have already x squared, so I have this. Then I have to multiply by 2, right? And I have to delete by 2, right? If I delete by 2, I will have this, b and x. I changed absolutely nothing. I multiplied by 2 and I divided by 2 and I split it. This is 2, b and x. And then I say, oh, okay, this would be u, this would be 2, x is u, then this should be v. So I add b divided over 2a squared and I subtract b divided over 2a squared, right? And then of course I have to do plus remaining part c over a equals 0. So I did nothing illegal. I just presented this like that, and then I noticed that I take this squared, add it and subtract. And if I do this, I immediately say that this is x plus b over 2a squared. Those three things. And the rest is this. And I can bring it to the common denominator if I want, because this would be a free number and it would be only beneficial for me. I do it, sorry about that, I do it slowly actually, not to make any mistakes. So I say b squared over 4a squared. This would be this minus, see? This minus. And this plus c over a equals 0. And then what happened, I actually completed to the full square, not using examples like in previous video of 2, 5, 7, whatever numbers, but I completed in the common form where b can be any number and a can be any number, not 0 of course because it's in the denominator. But then I have full square, so I write this like that, and I move this on another side, and when I move this on another side I have to change the signs, so it would be b squared over 4a squared plus c over a. And of course this is all absolutely the same. And now I want to come to the common denominator, so I'm running out of space, but that's okay. Let me delete all of this, remove all of this, and continue writing on top. So I have this x plus b 2a squared equals, common denominators here is 4a squared, right? And and I did one mistake here, because when I moved it there I forgot to change the sign here. I didn't forget to convert minus into plus, but I forgot to convert the sign to, so this mistake is fixed. I put here 4a, and I put here b squared minus 4ac. And you already see that I have this b squared minus 4ac, and I have a lot of good things going on. So I can extract square root x plus b over 2a equals plus minus square root of this b squared minus 4ac and divided over 4a squared. So I wipe it out. And I continue. I type x plus b 2a equals plus minus, and this would be b squared minus 4ac, and in the bottom there would be square root of 4a squared, which is of course x plus b 2a equal plus minus 2a. And here I will write square root of d, because b squared minus 4ac is discriminator and discriminant. And so what I have here is I made a square root, so I made assumptions that b squared minus 4ac, that this is a positive number. Because if it's not a positive number, it's impossible to do. There is no solutions. That's all I'm saying, right? Because if b squared minus 4ac is negative, this is always positive. So b squared minus 4ac would be negative number. Negative number could not be squared, I have to stop here. So this is where I have to stop, so I make assumption that this is positive, then I can do. Okay, and then what's left is minus b over 2a plus minus d over 2a, and I continue x12 equal common denominator to a, and here would be minus b plus minus, and that's it. And I derive this formula. So actually there are two solutions, and all based on this condition, which I assumed in the process. If this condition is not valid, there is no solution. So what I want to repeat here, what I did, I started with this canonical expression and I completed it to the full square. I completed to the full square, so I have a bracket squared, and then I said this bracket squared equals, and it equals something. And this is very simple thing that I can extract square root and be happy. And I extracted, and I did couple simple fractions, additions, and I received this number. So what I am trying to say, I wanted the goal of this exercise was to emphasize the method of completing to the full square, and also how you can apply it to receiving these formulas in the most generic form. Okay, and that completes today's problem, and I will go for the next one. And if you liked it, please like. If you want more, please subscribe, click bell, and ask your question, ask your problem. We'll be happy to answer. Thank you.